Welcome to chapter 4.3b lesson video. We're going to be talking about what makes a function either even or odd or even, or neither for that matter. So there's this term that we can use when describing a function, a graph, as we can describe it as being either even or odd. This is something you talk about a little bit in Math 3, but really pertains itself really well to these trig graphs. So let's go ahead and dive right in. Okay, so determine whether a function is even or odd. There's kind of two types of problems. There's a visual type, and then there is a computational type. We'll talk about both of those here shortly. Okay, so let's just talk about what a even or odd function is. So here we have even and odd functions. An odd function is a function that essentially inverts itself across the y-axis. Okay, what that means is that as we go right, it does the same thing as if we go left, but in an opposite manner. Opposite meaning one positive, one negative. So if I go to the right pi over 2, it goes up 1. But if I go to the left pi over 2, it goes down 1. An excellent example of a basic odd function is sine of x. So this is the sine of x graph. You can see it right here. And as we go to the right, it does what we do going to the left, but in an opposite manner. So anywhere to the right is a negative version. If we go to the left, there would be a positive version. So it's always just that kind of opposite relationship. Now, there's a way we could write this. We would write this as f of negative x equals negative f of x. So what this means is if I go to the right some positive amount of x, and I go to the left that same amount of negative x, so like go to the right 2 units and go to the left negative 2 units, the outcomes will be the same thing, but they'll be equal, but one is negative and one is positive. So they'll be the same numbers. So if I plug in 5 and I plug in negative 5, I'll get the same numbers out, except one will be a negative version of the answer and one will be the positive version of that answer. So that's odd function. So you kind of think odd, odd's different, right? So odd means that they're kind of opposites, right? One is a positive version of the other as we go left and right. So every time you go to the right, if you go to the left the same amount, there's the same number but opposite. Okay, even functions are the exact different definition, right? So rather than being inverted, they are mirrored. So as I go to the right and as I go to the left, the line will be at the exact same number. So your output will be exactly the same. So if I go to the right 3 units and I go to the left 3 units, that point on the graph will be the exact same number. Negative for negative, positive for positive, decimal places forever. So go to the right 7 and go to the left 7, it'll still be at the exact same height either way. Whether it's positive, whether it's negative, it's exactly the same. And so mathematically, what we're saying here is if I plug in some number and I plug in a negative version of that same number, they're going to be exactly equal. They're going to be exactly the same. This is different than odd functions. Odd functions, they were opposites of each other. This one, they're exactly the same. So visually, when we're looking at it, we're looking, does it kind of invert itself? Does one go up where the other goes down? Right? Or does it mirror itself perfectly? If I were to draw a line right here and go one side, go the other, does it look like it was placed in front of a mirror? Okay, and there's always the option that it's none of the above. It could be non-symmetric, non-inverted, and that's totally okay. So we have 3 examples here, and we'll go ahead and label them real quick. Normally in class, and I'll probably do this in our live session, I'll give you guys some, and you'll be allowed to talk me through which ones are which and why. So just in preparation for that, let's start the first one here on the left. This is our neither. This is our none of the above. Okay. Right, and the reason that is because if we were to draw a dashed line right down the y-axis right here, you'll see that it may kind of start to look like, as we went from left to right, this one goes negative over this one goes positive, but at some point it stops that mirroring thing. Here it bounces and goes back, but here it doesn't bounce and go back. So this is an example of a neither graph. It is neither odd nor even. It doesn't mirror and it doesn't invert. Okay, now our next example we have here, this is definitely an even graph. Okay, this is an even graph. You can see that as it goes down to the right, it does the same thing as it goes down to the left. Here, about 3 and a little bit, maybe, so I guess that's pi away, it bounces and heads back, and 3, it does the same thing over here. It bounces and it heads back. They both hit near 5 and negative 5. It's pretty much a mirror. You can see pretty clearly that if you were to draw a line right down the y-axis, it mirrors. If you were to fold it in half like a piece of paper, like a what's that called, hot dog style or hamburger style or whatever, fold the paper in half, the lines would exactly meet up with each other and touch. Okay, so that leaves one left. This last one is what we would call an odd function. So if we were to draw a line right down here, you can see that whatever it does on one side, it's doing the opposite on the other. Okay, so on the right side, it's going up to infinity, whereas on the left side, it's going down to infinity. Okay, now they can match at certain places, but the general idea is that they're, and usually that's on the x-axis, but the idea is that they're doing the opposite, because after it goes up to infinity, then it comes from negative infinity back down, whereas this one comes from positive infinity back to the middle line. So it's doing a mirror motion of sorts, but in an opposite way. Okay, so that's graphically, just looking at them, how we kind of see it. Okay, now the other way we can do this is we can do it in an algebraic way. Okay, so we can test whether something is odd or even. Okay, so let's just review the steps real quick, and then I'll try it with this example. I'll try a couple more as well. It says pick an input x that will not give you undefined or 0. So you're going to pick a number, and this number could be any number you want, but you want to avoid a couple things. You want to avoid something that's, when you plug it in, is going to equal 0, because you can't really compare things being positive or negative if they're 0, because 0 is neither positive nor negative. And you don't want undefined. So you don't want something that would make a denominator 0. You don't want tangent or cotangent or secant or cosecant values that would be undefined. The next thing you're going to do is you're going to plug that number in. So you're going to pick your number. I usually pick like 1 or 2 or 3, just some nice easy number. Plug that number in. You usually can use a calculator. So you might want a little calculator standing by. That's usually a great tool to have out. You plug that number in, and then what you're going to do is you're going to plug the exact opposite number in. So if you plug in 2, you're also going to plug in negative 2. I suggest you pick a number and just like always use the same number. Use 1, use negative 1, use 2, use negative 2. It doesn't matter. Whatever you want to use. I usually use 1, I think. That's just the easiest number that comes to mind for me. So you're going to plug that number in. So plug in 1, and then you'd plug in negative 1. And then you're going to look at what the answers are. If your answers are the same exact number. Now, I don't mean the same exact number to like 1 decimal place. 0.45 and 0.47 are not the exact same number. If it's the exact same number for as long as your calculator screen holds, then it's even. If they're opposite numbers, meaning exact same numbers, but one is positive and one is negative, then our graph is odd. And if they're just completely different numbers, like I gave that example of 0.45 and 0.47, if they're just completely different numbers, then you'd say it's neither odd nor even. Okay, so same exact numbers, positive and negative. So it's either they're both positive 0.2 and then they're even. Or if one is positive 0.2 and one is negative 0.2, then you'd say they're odd. Or if it's 0.2 and 3, then you'd say they're neither. Okay, so it's pretty easy. You just plug them in, you get to use your calculator. Sometimes we can do this with just a generic variable like x and negative x, but that can make things a little trickier. So let's just start with numbers. It's a nice way to, okay? So let's go ahead and do 3 examples here. So it's nothing too crazy. And so we'll just plug some stuff in and we'll see what happens. Okay, so I will go ahead and start with this first one. I'm going to go ahead and pick my number. I'm going to use 1 just because that's my number my go-to number that I like to use. So I'm going to go with the sine of 2 times 1, and I'm going to calculate the sine of 2 times negative 1. That's all I'm going to do. I'm going to calculate it on my calculator and see what happens, see what pops out. So the sine of 2 times 1, that came out as 0.9093. I'll go 4 decimal places. That seems pretty safe. And then I will do negative 1 as well. And for that one, I got negative 0.9093. 4 decimal places. I have a positive version and a negative version. So I will say that this function, sine of 2x, is odd. Okay, so it inverts in a mirrored manner. All right, let's go ahead and let's try our next one. So we have cotangent. So this is one thing that's kind of important. As you're doing these problems, if there is radians being plugged in like there is here, make sure your calculator's in radians mode and not degrees mode. That's going to be kind of a big deal. But I'll do my same problem before. So I'm going to do the cotangent of 1 minus pi over 4. And I'm also going to do the cotangent of negative 1 minus pi over 4 and see what happens. So 1 minus pi divided by 4, plug that into my calculator, and I get 4.588. Cool. And then I'll do the same thing, but with a negative 1, and I got 0.218. Oof. Okay, well, those are completely different numbers. Double check. I'm going to make sure my calculator is in radians mode because I plugged in a radian. I want to make sure it's just not some random number, that it actually makes sense that that's radians. I got these two randomly completely different numbers, so I will say this one is neither even or odd. It is none of the above in this case, and so that is okay. So I'm going to circle my answer. It says odd, and this one's neither. All right, and so we'll try our last one. So same idea, same exact idea. I'm going to plug in a 1 to the 4th power minus 3, and then a negative 1 to the 4th power minus 3. Now, be really careful when you're plugging this into your calculator because this 1 and this negative 1 are being raised to the 4th power. So I got to put that in parentheses when I put it in my calculator. So be really careful of that. So I'll go 1 in parentheses to the 4th power minus 3, and that gave me a negative 2. You could probably do this one without a calculator, to be honest, if you really thought about it. So that gives me a negative 2. And then I'll do negative 1 the same way. Make sure you put in parentheses if you're using a calculator. I also get a negative 2. And since they're both negative 2, they're exactly the same number, both the same sign as well. Both are negative. And so I will say this one is even. All right, so since they're exact same number, they're even. So opposites, odd. Random numbers, neither. Exactly the same, meaning positives, negatives, and whatever it is, even. Okay, with that, you should have enough information to be able to get started on the homework. There's some other graphing review on there as well. But if you have any questions, feel free to reach out. And in the meantime, I hope you have a great day, and I'll see you in our next live session.